Hi everyone, this is Professor H. Rahman from Agricultural and Food Engineering Department, IIT Kharagpur. I welcome you all to this NPTEL online course on traction engineering. This is lecture 34, where I will try to cover optimum ballasting for a front wheel assisted tractor. When I said front wheel assisted tractor, means it is a four-wheel drive tractor where the tire sizes are not same, like normal four-wheel drive tractor. So I will try to cover the concept is what is optimum ballasting, how to obtain optimum ballasting in case of front wheel assisted tractor. As I said, front wheel assisted tractor, from the outside it looks like a two-wheel drive tractor. That means the front wheels are smaller and the rear wheels are bigger, but they are powered wheels, unlike your two-wheel drive tractor where only the rear wheels are powered wheels. Okay. So now I want to find out what is the optimum ballasting conditions in case of a front wheel assisted tractor. Let W1 be the dynamic weight on the front axle and W2 is the dynamic weight on the rear axle. So I will take the help of G-Club's equations, who has developed a set of equations for predicting the performance of a tractor or performance of a wheel based on data obtained from 170 field conditions. So that's a huge number. So he has developed basically four equations you can see. One is related to CT max, the other one is related to CT, the third one is related to KCT max, and the fourth one is mobility number. He has also developed equation for rolling resistance, which I am not included here because we are not interested for the rolling resistance. Now if you look at the equation, whether CT max, CT, KCT max, they are all functions of mobility number, and the mobility number he defined in a different way. CIBD by W. Ci is the cone index, B is the section width of the tire, D is the diameter of the tire, W is the dynamic weight on the wheel. Square root of del upon H, del is the tire deflection under load on a hard surface, and H is the section height, into 1 upon 1 plus 1 plus 1 upon 2D. Now if you look at CT max, it is 0.796 minus 0.92 upon m, and CT can be related to CT max by an exponential relationship. CT is equal to CT max into 1 minus e to the power minus Ks, and this K is the rate constant. K CT max is given as 4.838 plus 0.061 m. Now with the help of this, I will try to derive equations for optimum ballasting for a front wheel assisted tractor. Now mobility number for the front wheel, assuming that weight is equally distributed among the front axle, among the wheels mounted on the front axle, and similar is the case in the rear axle. So mobility number M1, if I denote it as the mobility number related to front axle tires, then M1 will be equal to Ci B1 D1 by W1 by 2 into square root of del 1 by H1 into 1 plus B1 upon 2 D1. So for a given size of tire and for a given soil condition, the inflation pressure is varied with load, so that delta H remains constant. Okay. So I can write this as, because all these factors are almost constant except W, so I can write this as a constant K1 divided by W1. Here I have taken W1 by 2 because W1 is the weight which is coming in the front axle. Similarly, for the rear tires, the mobility number I denoted as M2, and this will be equal to CI B2 D2 divided by W2 by 2 into del 2 by H2 square root of this into 1 upon 1 plus B by 2 B2 by 2 D2. Again, for a given tire size and given soil conditions, I can take this as a constant K2 divided by W2. Okay. So the maximum pull which we can develop will be equal to CT max. We know CT max is nothing but pull upon dynamic weight. So now if I multiply CT max with W dynamic load, then I can get P. So from here I can say P will be equal to CT max into W. Now the total pull which will be developed by the tractor will be summation of the pull developed by all the rear axle tires and the front axle tires. So what I will do is pull maximum, this will be equal to W1 into CT1 max plus W2 into CT2 max, where CT1 max refers to the coefficient of traction, maximum coefficient of traction for the front wheel, and CT2 max refers to coefficient of traction and the rear wheel. We have got the expression for CT max. CT max is equal to 0.796 minus 0.92 by m. For CT max 1 or CT1 max, this can be taken as CT1 max m1, and for CT2 max same thing, only mobility number will change, 796 minus 0.92 by m2. So if I substitute here, then it becomes W1 into 0.796 minus 0.92 by m1 plus W2 into 0.796 minus 0.92 by m2. Now if I further simplify, 0.796 into W1 plus W2 minus 0.92, so 1 upon m1 plus 1 upon m2. Now I have to substitute for m1. In previous case we have calculated m1 is nothing but K1 by W1 and m2 is nothing but K2 by W2. So I can write this as 0.796 and W1 plus W2, I will come little later, minus 0.92 into m1 if I replace with K1 by W1, so that becomes W1 square by K1 plus W2 square by K2. And we know that W1 plus W2 is equal to the total weight, total axle weight on the. So for maximum efficiency, we are recommending from Doer's equation, Doer's ballasting recommendation, W by P axle is equal to 1.79 V. Okay. So, W will be equal to 1.79 P axle by B. For a given tractor and for a given forward speed, this part is a constant now. For a given tractor, this is a constant which I can represent as K3. Okay. Now, pull maximum I can write as pull maximum will be equal to 0.796 K3. So, I have replaced W1 plus W2 with K3 minus 0.92 into W1 square by K1. So, now I replace, since W1 plus W2 is equal to K3. So, W2 will be equal to K3 minus W1. So, I replace this one here. So, K3 minus W1 square by K2. Okay. So, if I further simplify, so I can expand this one 0.796 K3 minus 0.92 by K1 plus K3 square minus 2 K3 into W1 plus W1 square all divided by K2. Okay. So, if you want to maximize the pull, our aim is to maximize the pull by adding weight. So, dP by d W1 should be 0 if it is maximum. So, now I differentiate the right side. So, what I get is minus 0.92 into 2 W1 by K1. Okay. So, minus 2 K3 by K2 plus 2 W1 by K2. So, this should be equal to 0, okay, if you want maximum pull. So, from here you can find out expression for W1. So, W1 will be equal to K3 by K2 into 1 by K1 plus 1 by K2. Okay. Or this is nothing but K3 by 1 plus K2 by K1. So, what does it indicate? If K1 is equal to K2, what does it mean? That means the front wheel and the rear wheels are same. Okay. And W1 will be equal to how much? K3 by 2. So, if front and rear wheels are same, if front and rear wheels are of same size, then W1 will be equal to K3 by 2. Okay. K3 is nothing but W1 plus W2 by 2. So, this is the total weight by 2. That means weight on the front and the rear axles should remain same. So, once you find out W1 when the wheels are not same in size, Then you find out W2, which is nothing but K3 minus W1. So that will give you the required weight to be maintained in the rear axle, and W1 will give you the required weight to be maintained in the front axle to maximize the output. Output is nothing but your pull. Okay. So this is the way how to find out what is the optimum ballasting condition, which will give you the maximum output. So what we can do here is, we have got the recommendation from Doyers, and based on that recommendation we are calculating for the four-wheel drive tractor or the front wheel assisted tractor. So in this class I tried to discuss how to find out the optimum ballasting required for a front wheel assisted tractor, and how much will be the weight on the front axle as well as the rear axle to get the optimum ballasting that has been derived. Thank you.